the Common Core, and from Jim Lewis from University of Nebraska, Lincoln, and then Bill McCallum, University of Arizona.
So the name of this workshop was Mathematical Education of Teachers, and Sibylla wants me to talk about the mathematical education of teachers too, but in this sense it's a follow-up document to the document that came out a decade ago. Before we do, I think we ought to say how much we appreciate Sibylla's work organizing this meeting. And I think Bill and I are getting a certain amount of residual credit, and people keep coming up to me and telling me how good it is. I just want to tell you. But Sibylla discussed the need for an active, vibrant, interdisciplinary community that will drive a cycle of improvement in both the teaching of mathematics at all levels and knowledge about mathematics teaching. And she compared it to a research enterprise where you have a community that sustains itself and works to get better. Denise Spangler argued that knowing mathematics to pass a test was not the same as knowing mathematics in ways needed to teach it. She said teaching mathematics involves knowing representations, analogies, and so forth. Focusing on pre-service or in-service teachers' content knowledge is necessary but not sufficient. And then Deborah Ball talked about the need to teach something in particular and said that the Common Core might leverage radical improvement in teacher training. Well, let's hope. Many speakers talked about the Common Core and related it to their view on teacher education. Raven discussed study of elementary teacher education and two factors that she said made a difference. Use of a textbook written for a math course for teachers and teaching in a way that engages students with doing mathematics. So if we look back 10 years to the CBMS Math Education to Teachers publication, we said there were two themes in this, and I should say that Deborah Shifter was the author of the elementary school chapters, and Kathy Kessel was our editor. I think they're the sort of only members of the group in the room other than perhaps myself right now. But at the time, saying that there was intellectual substance to school mathematics and there was a special nature of math needed for teaching was not commonplace inside mathematics departments. And I referred to it as a quiet revolution. It was not so much an in-your-face, you guys do everything wrong, but it was putting in place something that we thought was both important and had potential for change. We also made a decision that the audience were the faculty in mathematics departments, the people who live and teach in math departments. And we hoped that the document would be useful to some other audiences, but we thought that by focusing on an audience, we had a better chance of doing something that had impact. And we grouped a bunch of recommendations around three categories. So I think it might be useful to take a look back at them a little bit. Teachers need math courses that develop a deep understanding of the math they will teach. Now, that might seem like, well, sort of everybody saying that. But I don't think everybody was quite saying that in 2000, 2001. And we said quality is more important than quantity, but people need the opportunity to learn. Because we'd been through a decade that almost had referred to seat time derisively as if an institution that offered one course for an elementary school teacher that could wrap themselves in nobility and talk about all the things they do in that one course. This was a move back to opportunity. It advocated for middle grades at least 21 hours of mathematics. Now, Raven said that when she did her study, her average was about 2.2, and the average in the CBMS study was about 2.4, which came out in 2005. We advocated for 21 hours of math, including 12 hours on fundamental ideas of school mathematics in grades 5 to 8. Now, we spoke of middle grades rather than middle school to at least subtly to imply that we meant 5th grade too. And there were a number of statements in the document that imply that. At the high school level, we said that it should be basically a math major, but it could include a 6-hour capstone course connecting their college math courses with high school mathematics. How many people's institution have a 6-hour capstone course to connect? I mean, we do. We use the Usiskin Stanley book. And And every single, what? Well, and saying some places require 2 courses in math, and some people for elementary, and some places require 4 courses for middle school. But so anyway, first thing we could do is just simply take stock of what's changed in 10 years and what's not changed. We argued for courses on fundamental ideas of school mathematics should focus on a thorough development of basic ideas, careful reasoning and mathematical common sense, advocated for the habits of mind of a mathematical thinker, and courses that demonstrate flexible, interactive styles of teaching. We said that teacher education should be an important part of mathematics department's mission, and that more faculty should become deeply involved in K-12 mathematics. We spoke of partnerships, cooperation between 2- and 4-year colleges, collaboration between math faculty and school mathematics teachers. And we talked about policies. We said that efforts to improve standards for school mathematics will be strengthened by the full-fledged participation of the academic mathematics community. Now, back in the days when Clinton was president and there was the voluntary national 8th grade math test, when they were going to have this committee, the word was that there were going to be no mathematicians on the committee. And so the AMS Committee on Education, Committee on Science Policy, which in some order were chaired by High Bass and myself, wrote a letter demanding that there were mathematicians. Now, be careful what you wish for. They put High on the committee. But there wasn't all that involvement. Now, the involvement of mathematicians and mathematics educators in the Common Core means there's been kind of a significant change in terms of the full-fledged participation of the academic mathematics community. Now, we kind of ducked professional development, and that's what the 10th recommendation is about. And we returned to the idea of the middle grades and said that math in grades 5 to 8 should be taught by math specialists. Now, so we might think about what's changed in 10 years. Well, we commented that the CBMS survey said there was an increase in the number of courses required of future elementary school teachers, and middle level, upper elementary is what I think it called them. And maybe the 2010 survey, which will come out sometime soon, will say there's been a continued shift in that direction. We'll see. And there certainly have been textbooks for teaching elementary teachers written by mathematicians. It'd be harder to document the degree to which the mathematicians are involved in teaching teachers. Or let's say the larger the university, is it more likely lecturers, part-timers, and graduate students do the instruction for future elementary school teachers. It's harder to document the mathematician-math-educator partnerships, or that coursework focuses on a deep understanding of school mathematics. I do remember a time when someone who taught for 15 years said, I'd love to come back to college and take another math course and get better. He says, but what would you do? You guys would tell me to take complex variables. I couldn't pass complex variables. It's been 15 years since I was in college. You don't offer me anything that's helpful to me, and that's why I went to the College of Education to take ed-psych courses. All right, now, both NSF and Department of Education have made a major investment in math science partnership. I think it's interesting to look at NSF's website, and they list 120 active math science partnerships. And for once, mathematicians and mathematics may be receiving sort of its share, and even maybe more than its share, of NSF dollars invested in math science partnerships. Mathematicians are heavily involved in MSP work, not just in offering advice or teaching math courses sort of on the outside looking in, but in leading MSPs. Here's a list, and I'm sure I should know many more, of math science partnerships that are led by mathematicians. And certainly people in the room like Bill McCallum wrote one of them, a PI for the Arizona Teacher Institute. And so there is a lot of involvement of mathematicians and in the mathematical education of teachers. There's some major national programs like Park City, Intel Math, Math for America, UTeach, that are also trying to make a big impact on the mathematical education of teachers. And there's MSRI. MSRI and its critical issues workshops, in particular the one 4 years ago that you can get the brochure out there, Teaching Teachers Mathematics, and this one on the mathematical education of teachers, has focused an awful lot of attention on the issue and in a very real sense, legitimize the work among mathematicians and research mathematics departments. You can also get this brochure out there. This was a workshop on mathematics educator partnerships, but sad truth is there just weren't very many, right? There simply weren't very many. Now, but you might say more than ever, there's an awful lot of reasons that we need to strengthen the mathematical education of teachers. And so we're setting out to revise the MET project. How do we get started? Well, slowly, because a lot of very busy people. But it's received funding from Math for America.
Only one very busy person.
And CVMS. Its goal is not to replace, but to enhance and extend the current document because of the belief that the current document is still quite useful, all right? And its recommendations in particular, everyone I talk to seems to think they're still relevant. Stay the course on those recommendations. But that the other document did not address professional development. And if you think about how different it is 10 years apart and how much is being invested in professional development, then certainly this new document should say more about professional development. The environment, it does in many ways seem better than the math wars of about 2000, 2001, replaced by such things as the Common Ground Initiative and now the Common Core. And there is really remarkable agreement that on the importance of the teacher if we want to improve our schools. Here's a bunch of names, and you'll recognize an awful lot of them. All of these have in one way or another said that they'll be involved in work on the MET2, and there are more people to be added to the group, we hope. And so I want to give you a couple of issues that I think we have to address, and I'll try to phrase them mainly as questions. First, the Common Core seems to be the 300-pound gorilla. How does it impact what we should be saying about the mathematical education of teachers in a way that 2001 was just after the release of PSSM. And while that was a major document, it did not seem to drive all our decision making or all our discussions. But I think, somehow I think this, with so many states signing on the Common Core, this is different. We still have to address who is the audience. In particular, if we say that we're going to be involved with professional development, the audience can't just be people who live and work in math departments, but the sooner you start having multiple audiences, the more your message is spread out and doesn't work as well. And so, what are the special challenges resulting from a decision to address professional development in this document? Can we make the case that learning mathematics should be a substantial part of professional development? I had someone last Friday advocate to me that we should say that 2/3 of all professional development should at least be content-based professional development. They believe that vast quantities of dollars will go to professional development, and they'll all be about professional learning communities and other things that are basically content-free approaches to improving school education. Should you object to K-8 certification of elementary school teachers if, in fact, it's basically preparing K-4 teachers? Right? Or is it like this old Peter Sellers movie, How to Quit Worrying and Learn to Love the Bomb? All right. Should 5th and 6th grade teachers be educated as elementary teachers or middle-level math teachers? I mean, we advocated somewhat quietly that they should be educated as middle-level teachers, that when this intellectual transition to fractions and the like become a large part of the curriculum, the sort of cognitive difficulty has changed significantly, and the teacher has to know a lot more mathematics. What's the appropriate mathematics education for early childhood educators? That wasn't even on our radar screen 10 years ago. What's the appropriate math education for math coaches or elementary math specialists? How should that be different from just educating teachers? Are there ways to significantly improve the mathematical knowledge of large numbers of current elementary teachers? This is an incredible problem of scale. And just think in your own community, if you had to find the dollars locally, or if you think of the number of teachers in America, it's a remarkable issue of scale. So the National Math Panel said that there were basically sort of two ideas, sort of how to get around trying to educate everybody that teaches elementary school, math coaches or math-intensive instructors. But in some sense, the jury was out of whether one was a better approach than the other. Either better because it leads to better education for all kids in elementary school, or better because it's financially feasible. I mean, hire a coach, you educate and hire a coach, then you have one extra salary in your school, or more than one extra salary in your school. If you provide professional development for some, but not all, who teach 2 or 3 math classes, then in essence you would be using your resources, your human capital of people who want to teach mathematics efficiently, and each person doing the thing that they want to do. I know great first grade teachers who are passionately afraid of mathematics, and they're still great first grade teachers in terms of working with kids and teaching an awful lot of what the first grade curriculum does. There is, we could say, the space, the opportunity to learn in a college degree, with universities saying, no, you can't have 135 hours required for the lowest paid profession in America. You have only so many opportunities. What choices will that force with respect to the opportunity to learn mathematics and what mathematics is taught? Earlier we were talking about the problem at Georgia and the decisions being made by elementary education to back away from the opportunity to learn mathematics. And so, do you prepare the teacher for the first day of class or for a lifelong journey as a teacher with the initial certification? What knowledge experiences are desirable for a high school math teacher, and can this be provided as part of an undergraduate math major? And is the answer different for a different type of institution? I had someone in a research university within the last week basically told me that the attitudes of math faculty are a fixed point. They're going to educate people for graduate school, and that you have to just give up on it and start with professional development right after they get their degree. Now, I hope is not the right answer, but when you think about the priorities of math departments, and do they offer courses, for example, that teach future high school teachers how to do what people call task design. How do you get a triangle with integer coefficients and a 60-degree angle? All right? Not a simple task. And where in the education that they have as an undergraduate math major helps them understand the mathematics for doing that task? Must teacher preparation programs try to prepare high school teachers for their complete career, or should we give up on things like being ready to teach calculus or statistics and say, well, in the beginning, first, a new teacher is an Algebra 1 teacher. Let's prepare high school teachers to teach Algebra 1, geometry, maybe Algebra 2, and then continuing professional development continues to expand their capacity to teach. I don't know. You have to make a decision of what to do with the opportunity that you have. Should passing some type of math exam be a required part of certification to be a math teacher? So there are loads of questions related to what we should be saying, and the group that will be involved in this is trying to sort out what is it good to say and what is it insanity to say. So I'm going to close with a couple of things. First, here, the challenge of teaching mathematics is a very old issue. I want to read a quote to you. One of the first questions which a student asks at or near the beginning of his study of any branch of mathematics is, what is it good for? In most cases, he is not satisfied unless he can be shown some specific utilitarian use to which his new knowledge may be put. Later, it must be acknowledged, however, that a student of good mathematical ability, or one who has been well taught and has followed a well-arranged program of mathematical study, oftentimes is apparently unable to apply his mathematics to the study of a new science. In other words, he seems to lack that mathematical habits of mind at which we have aimed. This appeared in the Math Monthly in May of 1910. And my thanks to Rich Milburn for showing this to me. All right? So the phrase mathematical habits of mind, and the idea that in some sense collecting facts and actually being able to do certain procedures still sometimes doesn't have the desired effect of being able to use mathematics. But there is good news. Last night on the website I was looking at said that CareerCast says the 2011 best jobs out of 200 jobs are software engineer, mathematician, actuary, statistician, and computer system analyst. And of the list of 10 least stressful professional jobs, the best paid of the 10 is mathematician. All right, so there's reasons for all the teachers to tell their students they really should study mathematics. Thank you.
Instructors of the courses in my data set, only 25% of them reported being very familiar with MET, and 50% reported being not at all familiar. So one thing that I think your group should attend to is how to get this into the hands of the people who would most benefit from reading it. These are instructors of math courses for teachers, and 50% of them really had never even heard of the document.
We're people interested in the mathematical education of teachers, and how many of us have read over half the documents that Joan Monday flashed in front of our eyes today? I mean, I was writing a list of documents.
That one is particularly important because it has so many good ideas.
Raven, I absolutely agree with you. The idea of, I think earlier today I was in a conversation that in a subfield of mathematics, if someone proves a theorem, accomplishes something, it gets added to the knowledge base of the people who are interested in that field. An awful lot happens with regard to education or mathematical education, and that its sort of dissemination to people is just a little like a Pony Express. And that's a very real issue. I agree with you.
Just wanted to make a comment. In one of your questions, you said, should 5th and 6th grade teachers be educated as elementary or middle school teachers? I would suggest that the person should probably be educated as elementary or high school teachers. Because what has happened is in middle school you get elementary teachers. In other words, people who haven't had deep knowledge of mathematics teaching algebra to middle school kids.
One of the challenges that any group of this sort faces is whether to set in front of people goals that you think has a possibility of being achieved, or the answer that you think is the right answer. And 10 years ago, 12 years ago, we were debating whether to argue that elementary school teachers should have at least 3 courses in mathematics or 4. And at the time, I argued, for example, we had to be pragmatic. The thing, Every Child Mathematically Proficient, that was put out by whichever group put it out, in essence, the 15 300-pound gorillas of education in a consortium had this thing, Every Child Mathematically Proficient. They were advocating for math specialists starting in grade 5 and 3 math. So it seemed to me that we should advocate for things that might be part of a movement that might have some chance of happening in my lifetime. And so I don't have any disagreement with your advocacy, but I don't see that happening in America unless you go past the point of saying you should not certify a 5th grade teacher with an elementary school certification. And given the magnitude of the number of people who teach elementary school and the likelihood that schools will change away from a model of the generalist, it's almost a pragmatic issue. And so I have no disagreement with your belief of what would be great for teaching mathematics.
Yeah, it's just that if I think about our program at MSU, I don't know where middle school is because we have primary or secondary. So I would say secondary. Yeah.
I think I know you guys are interested. One of the things that really concerns me is the separation of pedagogy and content knowledge. I don't see why those two can't be, in terms of professional development, intricately linked through all of it. Same with in terms of teaching teachers versus teaching the teachers. Could the teachers be part of the learning of the students with the math specialists? I mean, I just see that there's sometimes an unnatural separation that doesn't really need to be there. And if it's a little more holistic, we might be able to answer.
So, another wine is waiting, and so let us switch to Bill.
So I just want to talk a little bit about some projects that I am aware of or that I'm involved in that are follow-on projects for the Common Core, helping implement the Common Core and providing tools for implementing the Common Core. All of the projects that I'm going to talk about and more are on my blog called Tools for the Common Core Standards. I just want to mention that now because I'll probably forget to mention some things. And I actually don't have any. I don't have any on-brain memory left anymore. It's all on my computer, and so so if you go here, you can sort of explore around, and I announce things when I hear about them, and if you have projects you want me to publicize, I'm happy to do that too. The two big projects that I want to talk about are projects that were originally intended to be part of the Common Core. Just to give you a little bit of background, when this big work team of people came together to write the Common Core State Standards, it didn't start out by writing the standards in the form you see them now. It didn't start out by writing grade-by-grade standards. It started out, the way we managed the work was to ask people in the work team to submit drafts of progressions of mathematical ideas across grade levels. So we came up with some sort of classification, some topic, some domain headings that we wanted people to write on: number and operations in base 10, operations in algebraic thinking, fractions, geometry, and so on. And then we went to the work team and solicited from people who are expert in various different areas, essays essentially, we called them progressions, that described the way mathematical thinking would go in a student across a certain span of grade levels in that domain. And once we had these progressions, we sort of tried to fit them together into standards. There are obvious ties between progressions that you can think of. For example, multiplication in number and operations in base 10, maybe you should design your standards so that that occurs in the same grade level that area is being studied in the measurement domain. So there was a process that started out with progressions. At some point they got arranged and sliced into grade level standards. That was that first draft of grade level standards that some of you might have seen came out of that process. Then we got into this cycle that was used to develop the standards. It's a novel method of writing standards that I call the cycle of premature release followed by savage criticism. We went through that cycle for about 4 or 5 times, 6 times internally with the standards writing team. Our clients, our clients were the states who had signed on to the Common Core Standards Writing Initiative. So so we had to keep sending these drafts out to the states for review, and then there was also an official feedback team, and there was a validation committee, and then there was a series of organizations that also were privy to these early drafts, and this all eventually resulted in the public draft in March. And and the rest is history. But so the point is, those progressions fell by the wayside in this process of revising the standards themselves. So one project we have is simply to clean that up and to sort of finish that job. So that's what I call the progressions project. And that project takes long. There's a bit of a gap between. Okay, there we go. That project, we've been slowly releasing the progressions. Basically, the original members of the work team who wrote these progressions are now sort of getting them into final form to fit the standards as they finally came out. And so we have, if you go to the, there is an official website for this, but it seems like this is easier to get it. If you just click on the progressions category here, you'll see a series of posts where we've put up draft progressions on number and operations in base 10, draft progressions on expressions and equations. There's actually one that I obviously have failed to tag correctly. The most recent one is this draft progression on counting and cardinality and operations in algebraic thinking K through 2. And just to show you what these progressions look like, they're basically documents that simply have I'm not expecting you to read this, but they have a narrative description of the standards, and they're arranged so that you have the sort of the narrative in the main text there, and then the standards themselves pulled out in the margin on the right. So there might be a useful tool for people trying to dig into the standards, in the sense that you can either read them as a narrative and look at the standards as they're referenced, or, and this will especially be true once we get this up on the web into some sort of web resource, you'll be able to go the other way, look in the margin for a standard you're interested in, and find the associated sort of narrative that goes with it. And every now and then you'll find, let me see if I can find one here, pretty pictures in the margin, and illustrations and examples and commentary. And Kathy Kessel has been doing I don't know where she is. Anyway, wonderful job of editing these. Sibylla has been involved in the writing. So that's the Progressions project. And we intend these as well, partly I think we intend it just as sort of fulfilling promises, since we said we were going to do it. But we think they might be useful for people trying to maybe design professional development. They just might be useful for clarification. There are certainly glitches in the standards that can get clarified in the progressions. That's project number one. The other promise we made, foolishly, was that the standards would come out with illustrative tasks. And I think everybody was begging for those. Everybody thought this was a great idea. They said, really glad you're planning to do that. And so we felt that maybe we should do it. If not, we couldn't do it at the time, but that's the Illustrative Mathematics project. I think that's a much bigger task than anybody thought, than anybody anticipated, certainly than I did. So that's a project that is, at the moment, just has a very sort of, it has a basic website which has the standards displayed, but not the tasks yet. But just building the machinery, the web machinery, to have this flexible way of displaying the standards has taken some time. So I'm just pointing this out to you because it might be useful if you just want to, if you want to navigate the standards, it might be it's sometimes easy to navigate them with this online presentation, so you can navigate standards by grade level just by clicking on the grade level. You can expand and collapse cluster headings and domain headings, or you can navigate them if you want to explore all the standards across a grade level in a certain domain. You can navigate, you click on number and operations in base 10, you get the grade K through 5 standards. Again, you can sort of expand them out and contract them down, and you can just sort of see them all at once if you want to. So that is the web infrastructure to which will be attached these sample tasks. We're currently in the process of sort of putting together a team of checkers and vetters for tasks. The Illustrative Mathematics project has this sort of on the face purpose of simply providing a tool for educators, teachers, curriculum writers, test developers, to simply have a place to go and look for examples. It has a sort of social engineering aspect to it as well under the hood, which is that it will be a website where people can submit tasks. There will be a sort of team of people who vet them and check them. It'll be a sort of social community building itself as it goes along and developing a notion of what is a good task, what is a quality, what tasks show craft. Just the very fact that there is craft in writing tasks. There'll be, you can imagine if you're a teacher, you have a good idea for a task, it gets submitted. If the process is respected by which these tasks are checked and edited, then your task gets published. The fact, if your task gets published, that's a sign of an achievement that you could then take professional pride in. So there's a sort of sense in which we're trying to build a community of people that are thinking of the craft of writing tasks in a professional way and sort of commenting on each other's work, communicating with each other, and sort of providing a place where they can talk about the standards. And the ambitions for this project go way beyond what I've just said, but anyway, hasn't even got any tasks there yet, so I probably shouldn't talk about the other ambitions. But that's a project which we're involved in, and two of the people here Heather Callahan and Kristen Umland are involved in that project as sort of team leaders for the high school and the middle school teams. And Kim Rimby, who's not here, I guess, is in charge of the elementary team. So that's the Illustrative Mathematics project. There are some other things for which I'll just refer you to my blog that are going on. NCTM, ASSM, NCSM, and AMTE have a project. They had a task force that came out with recommendations. They've now formed a sort of gang of 8, but it's not called that really. It's called something else.
It's the Mathematics Common Core Coalition.
Mathematics Common Core Coalition. Diane actually mentioned this, I believe, in her opening remarks, which has all sorts of things going on. I have an announcement about it here somewhere on the blog, but I'm probably out of date by now on where it's going. So if you send me something, I'll put it up there. Bill Bush's project to develop analytical tools for looking at curriculum that Diane also talked about. There's a description of it here. There have been various professional development conferences that people have had, and some of them are described here. I will mention one project. We had the Institute for Mathematics and Education a few weeks ago. We had a meeting of people from certain states, mathematics educators who have professional development products, mathematicians, to get together and issue a report on what are the key targets, not key, but just like what are the initial targets for professional development around the Common Core that you might focus on if you can't think of anything better to do over the next few months. And part of the point of this was to have a very rapidly released report that just made some recommendations that had some consensus support behind them, because we had the impression that there are lots of state departments of education, that are basically panicking right now. They're thinking, oh my God, we have to implement the Common Core next fall, or various states have different plans. Some states have a rational plan where they start in kindergarten and then go from there. Others, David Wright, I think, is left, right? Utah has a plan where they're going to implement the initial grade levels in which they're going to implement the standards are grades 6 and 9. So anyway, we thought it would be useful to put out a report with some. So this report has 5 initial targets of professional development. Basically, it's sort of saying if you can't think of anything else to do either, counting and cardinality in kindergarten, fractions in grades 3 through 5. And so that report here is on the blog. It's in draft form at the moment, and I welcome comments on it if you want to go there and just submit them on that thread. In fact, same goes for the progressions. There have been some very rich comments submitted by people who've read the progressions documents, some good discussions going on the blog there about that. Those progressions that are up there are also just in draft form at the moment, so they're not the final form, and still interested in hearing people's opinions about them. On the issue of professional development, I just want to briefly mention a project which does not exist, but I wish it did. And listening to all of the presentations here at this meeting, there ought to be a project on professional development around the Common Core. There ought to be some big national effort to pull together things that are that will support teachers in the Common Core. There ought to be somebody thinking about online professional development, something that can be done at scale. I tried part of the point of having this workshop was to somehow at least get something going about thinking about professional development. I actually ran, in collaboration with the PD people in my local school district, 3 one-day workshops on for elementary school teachers on the Common Core, and I hope that out of this conference something of that comes up. So I'm getting the signal from Sibylla here. It actually reminds me of something that I found extremely helpful when I was writing the Common Core, and I recommend it maybe as a possible tool for implementing the Common Core, which was alcohol. And I believe that there is wine out there for after her. What? Oh, the schedule says, okay, all right. All right, well, okay, so that's good. So I needn't have worried that I was standing between you and the wine because Herb is.